In this video, we'll try to understand what exactly is Raspberry Pi Pico. You might have heard or read about Raspberry Pi Pico or Pico W in several different blog articles, maybe into a newsletter or something like that. You might have also heard about Pico as well as something called RP2040. In this video, we just want to explore what is Raspberry Pi. So if you have similar questions like, okay, I have heard about Raspberry Pi Pico, but what exactly it is, or what exactly is RP2040, then this video will clarify all those doubts for you. Let's get started. Now, Raspberry Pi Foundation, I'm pretty sure you know about Raspberry Pi Foundation so far. If not, I'll just tell you a short history. So Raspberry Pi Foundation is a UK-based foundation, which is a non-profit organization which developed the world's first cheapest complete computer system called Raspberry Pi. This computer is capable of running Linux operating system, and when it started, they created a 700 megahertz 128 MB RAM single core processor PC. Till now, it is a dual core ARM 1.5 gigahertz computer with 4 GB or 8 GB of RAMs. So it has gone a long way. And the price point has remained the same. Raspberry Pi computer still comes at $35 price point, and it's a credit card size computer. The primary intention by the Raspberry Pi Foundation was to assist the education industry, to assist people to be able to purchase a computer within their budget and learn computing. However, it so happened that the embedded system community or the developer community jumped on the top of Raspberry Pi and instantly made it the most popular, the most widely sold or largely sold computer in the world. Raspberry Pi is now today's most or highest sold computer in terms of total number of units sold. So because of this, the Raspberry Pi Foundation grew largely, and now recently they have also created their own microcontroller. So where Raspberry Pi was a complete computer system, RP2040, it's something that Foundation created, which is a microcontroller. A microcontroller is useful for any kind of real-time embedded system applications, and it can be used to create general purpose or specific projects. So let's first discuss what is RP2040. So 2040 is basically a microcontroller designed by Raspberry Pi Foundation. It is built on the ARM's Cortex M0 architecture, which can work at a maximum frequency of 133 megahertz. It has a built-in 264 KB on-chip RAM, and while the development is done by the Raspberry Pi Foundation itself, therefore, from the development of controller itself, they have created a CC++ as well as a MicroPython software development kit for RP2040, which essentially enables anyone to experiment with RP2040 either using C language on any kind of IDE or using MicroPython language. So MicroPython is a microcontroller specific fork of Python. It also allows the micro machine learning using the TF Lite. More onto it you will get to know slowly as you progress during this course. Now this is about RP2040. I'll again go into a bit more details about RP2040. But before that, let's try to understand what is then PICO and what is PICO W. So microcontroller is just like this, a single chip which you can buy. You can create a board around it, you can create a system or design a system around it and use it. But PICO is a line of boards which Raspberry Pi Foundation has created, which makes it easier to experiment with RP2040. If you are familiar with Arduino family, then consider RP2040 as the Atmega microcontroller, Atmega 328 controller present on Arduino Uno board. So Uno board means the Pico board, and Uno has Atmega 328. Similar to that, Pico has RP2040. There are two different boards developed by Raspberry Pi Foundation. One is called as PICO and another one is called as PICO W. The difference essentially is only one thing. Raspberry Pi Pico is a simple microcontroller board, just like a replacement or a much powerful replacement to Arduino Uno or Nano, whereas Pico W is the same with an additional feature that it has a wireless interface as well. You can connect Pico W to internet using Wi-Fi, and you can create IoT applications with Pico W directly. This is a big availability that you can create IoT projects directly using Pico W board. Throughout our course, we are going to use Raspberry Pi Pico W. However, all the things that we cover will be exactly applicable to Pico as well, except the part where we connect with the network or with Wi-Fi. So this is the difference between Pico and Pico W. More details if you want to go into Raspberry Pi's microcontroller RP2040, then these are some of the additional details. As said, it has got a 264 KB on-chip RAM. Then there is a 2.4 GHz 802.11n, which is nothing but a Wi-Fi standard wireless LAN. It has got 26 multifunction GPIO pins. GPIO pins means general purpose input output pins. Means you can interface 26 different things directly with RP2040 using those pins. This 26 multifunction GPIO pin also includes 3 analog inputs, meaning that 2040 also has an ADC onto it, and you can directly connect analog sensors. This is about the basic things, GPIO and ADC. Apart from that, it has also got some communication interfaces like UART, which is a serial port, Universal Asynchronous Receiver Transmitter. So there are two UARTs, there are two SPI controllers. SPI is your Serial Peripheral Interface protocol. This allows a very high-speed data communication and is mostly used to interface things like the memory cards or flash chips. Then it also has two more I2C controllers. I2C is a two-wire protocol with which things like a real-time clock and a lot of different sensors can be connected just with two lines of controller. And there are two I2C interfaces on RP2040, and we have 16 PWM channels which can be used for speed control applications the way we want. 2040 also comes with a USB 1.1 controller with host and device support. Host and device support means you can use it as a host and connect a pen drive to it additionally to Pico itself. Oh, sorry, to RP2040 itself. And device means you can connect the system to a computer as a device, maybe if you want to share some kind of data or you want to transfer some data to and fro. The supported input power. Now this is not for 2040, okay? 2040 works purely on 3.3 volt. The supported input power mentioned here on is for the Pico board, 1.8 to 5.5 volt. It has got an accurate on-chip clock, temperature sensor, as well as accelerator, integer and floating point libraries which are present on chip. Combine this with the RP2040, combine this with the Pico board itself, the whole package is a very nice experimentation and fun device that you have at your disposal. You can not only simply experiment with it, but using this device, you can also create any end application directly. This is the pinout of RP2040. You will find it on multiple places, but I would say go to the raspberrypi.com website and you will find it from there. When we do any kind of experiments like this, we usually take a printout of the pinout and keep it in front of us. I'm going to do that while I create this course as well, and I would request you also, if you can do that, better. If you have it always in front of your eyes, then it's very easy to identify, say pin number 4 is GPIO 2 or pin number 22 is GPIO 17. If you count all the GPIOs which are listed here, you will find that there are 26 pins which can be used, and each pin may have a different purpose. For example, pin number 29 is only GP22, but pin number 7 is UART pin, I2C pin, SPI pin, as well as general purpose pin. Through programming, you can decide the nature, what exactly the pin will do, and you will understand that thoroughly when we study the Pico board in detail. This is the pinout of Raspberry Pi. It comes with a micro USB connector. And these are some of the important links where you can download the documentation of PICO. Hope this gives you a nice boost to your understanding with the PICO board and RP2040 overall. For more information, you can always go on to these links and download the documentation, official documentation. The official documentation, it's so simple that you can also treat it like a book instead of a data sheet. Usually reading a data sheet is very boring affair, but the RP2040 documentation is really very nicely laid out, and it makes it easier for us to directly get started understanding the architecture if you're interested. That's about it for this video, guys. Hope you will understand more in upcoming few videos. Keep experimenting with RP2040. Thank you.
PICO W, that is primarily intended for wireless applications like IoT applications. So in this video, we are going to see how we can get started with Raspberry Pi PICO W with MicroPython. We want to program Raspberry Pi PICO in MicroPython, and many people will find issues when getting started with Raspberry Pi PICO. So let's get started and understand what is the process for it. Now, when you have purchased a new Raspberry Pi PICO, it may or may not have the MicroPython firmware that you require it to have. So the very first thing to do is, before connecting Raspberry Pi PICO to computer, or if you have connected it already, then just remove it from it. And then you will find a reset button onto the PICO. So what you need to do is remove the cable from computer and then press on this reset button. And while the reset button is pressed, what you need to do is you need to connect the PICO to computer. In this way, what happens is the Raspberry Pi goes into the boot mode and it will open up as a pen drive or mass storage, just like what I did. Mind well that I am doing this tutorial on Windows 11. So what happens is it opens up a drive just like this, and here you can go to this index.htm, which will guide you to the documentation of Raspberry Pi PICO W. Now on this page, let me just close my presentation full screen. Now on this page over here, you can see the documentation and how to get started with PICO W and MicroPython. I'll just go to MicroPython link over here and it will give me what I need. So what you need to do is you need to download this MicroPython UF2 file on your computer and then to your board. So just go to this PICO W, or if you have PICO, then PICO. I have PICO W link. It will download the UFT file. Now I have got this UFT file over here. All you need to do is simply copy that file and go to the RPi RP2 folder and paste it over there. After you paste it over here, the Raspberry Pi PICO W module will reboot itself or restart itself. Yeah, as seen, the drive is gone and it starts rebooting itself. But what happens is, if you have seen, and many of you might have faced this issue, if you open the device manager, you will see the USB serial device like COM3 over here. But when you open or when you try to connect to it, you're not successful. Let me show that to you through some series of steps itself. So to use MicroPython onto it, what you need is a software called Thorny. You can download Thorny from the official website, which is thorny.org. You can download the latest one from this place, which I have already done. And now I'll simply open my Thorny instance. And when you open Thorny on your computer, you have an option to select the Raspberry Pi PICO from over here. And this is the issue that I'm facing. So by default, you can use the local Python 3, which will use the Python installed along with Thorny on your computer, but we don't want that. So if you just look at here, you can change it to use it on Raspberry Pi PICO. It has two instances, MicroPython Raspberry Pi PICO COM3 or MicroPython RP2040 COM3. Either one of them is not working for me, and I'm pretty sure you might have faced this issue yourself as well. Now, why I'm getting this error, if you try to dig it down a bit more, then if you go to device manager, you will see that the COM port which has been assigned to your computer or your Raspberry Pi, which looks over here. So the COM port is there is no doubt in that, but there is a symbol which says it's not working correctly. I'll remove the board now. You will see that it's gone completely. I connect it now. You will again see it, but with the symbol. As long as this symbol is there, you will not be able to use MicroPython on your PICO board. Now, what is the workaround for it? The workaround is very simple. All you need to do is you need to go to the MicroPython website instead of the Raspberry Pi website. Let me just remove the other unwanted tabs. So, let's go to micropython.org and go to download option over here. When you go to download, it will show a list of different boards. Just a minute. For which you want to download the MicroPython UF2 firmware. Here you will have to find your board. There are loads of them. What we are interested in is Raspberry Pi PICO or PICO W. This is where I find PICO W, and here I will find all the different ports available. As a usual thumb rule, what I do is I use the oldest one which is available on this page. So I'll simply click the last link. It will download the firmware for me. So I have this firmware now. I will copy it, delete the previous one, and push my Raspberry Pi into again the debug mode or the boot mode. Switch pressed, cable removed, cable connected again. Now I'll paste it here, and while Raspberry Pi reboots, I'll just open my device manager. It shows RP2 boot as long as it's in boot mode, and as it's restarted, it should show you a COM port. Now you can see USB serial device COM5. It's showing clearly, no issues at all. Now I don't know why this is happening, but if you follow the official UF2 file from here, it's giving me a problem. Most probably that is happening for my Windows 11 system. I don't know what happens on Windows 10. But if you are facing this problem on Windows 10 as well, simply go to micropython.org, download the UFT file from there and install it. Now let me see if I can connect to this interpreter. So I'll switch to local Python 3, and from here I will again switch to COM5. Now when you choose your COM5 MicroPython, see it's working well. Let's just try a simple hello, and that should confirm our working. That's it. Now this has given me lots of frustration. I hope it will save you your frustrations as well. Thank you for watching this video. Get started with Raspberry Pi PICO and start experimenting on IoT.
Hi there. In this video, we'll try to see how you can run your first program on Raspberry Pi PICO board and how you can run it in a boot mode, so that whenever you restart your microcontroller, your program should start working. Now, for the sake of this code, I will not go into the details of MicroPython. We are not studying MicroPython here. We are simply trying to create our first LED Blink program, and we are trying to run that program in boot mode for Raspberry Pi PICO W board. Now, unlike Raspberry Pi PICO, on PICO W board, the LED is connected to a wireless interface pin. So it's not connected to any of the GPIOs, as you can see here, and it's directly connected to this WL GPIO something pin. We'll see how you can interface or how we can connect with this pin and how we can write a code for it. Just some heads up, these are some of the important declarations we are going to use in this program to blink the LED using MicroPython. As said, the discussion about what is this, what are all these different lines are, they will come in follow-up videos. I also written the line here that on-chip LED on PICO is connected at GPIO 25, but on PICO W, it's connected to a wireless controller pin, referred to as simply LEB in MicroPython. Let's try to create a code for it using these declarations, and let's try to run it on Raspberry Pi and then try to run it on a boot mode, or whenever the Raspberry Pi is powered on, we'll try to run it at that stage. As always, when you open Thorny, if you have the Raspberry Pi Pico connected using USB cable, check it over here. It should show the COM port number. Now let's write down the lines over here. So this is important. This is important. I'll also write down this import time. We use the time library for adding the delays. Now there are multiple cases where the program can go wrong, and I'm not going to do anything wrong here, but I'm just going to show you the right steps so that you follow the same. So whenever you write a program, I'm going to write my complete program here now. So led.on time.slip1, led.off time.slip1. Now once the program writing is done, what we do naturally as a first step is we save the code. So while saving the code, you have two options. Either you can save this program to your computer. It will still run on Pico board for sure. Or you can run it on, or you can save the program on Raspberry Pi Pico board itself. Now remember, if you store your program on this computer, the program will only run when you click on this play button over here. And when you click on the stop button, the program will stop. But it will not run by default like an Arduino or like any microcontroller program. In order to make that program run like a microcontroller, whenever you power on or whenever you cycle the power on off on Raspberry Pi Pico, you need to save it on Raspberry Pi Pico board. So select the second option over here. Now here again, there is a catch. So if you save your program like this led.py, there is a program onto this Pico already. I'm deleting it. If you save it with any other name which is not main.py, then the code will not run in boot. If you want your program to start running whenever the Raspberry Pi is powered on and off, you must write the name as main.py. Now what I'll do is I'll make a mistake here. I'll make it main2.py or main23.py, something like that. And I will save it just to see what happens. Okay. Now my program is saved. I'm keeping the Raspberry Pi board a little bit closer to camera. Let's wait for focus. Okay, it may focus or not. Just let me put a finger so it focuses fast. Yeah. Now I'll run the program using this play button. Now if you see, the LED is blinking. Correct? Code has started working. Now what I'll do is, I will stop the program running from here. And now, I will simply remove the cable and reinsert it. So this is my power cycle. Ideally, like an Arduino, what I expect is whenever I connect the power, the program should start working. In this case, however, we will see that the program is not running. But if I click on the play button again, it will start working. Okay. Now, the obvious question is, if we are creating a system around Raspberry Pi Pico board, then we don't expect someone to open Thorny and simply click on the play button or stop button, right? What we expect is the program should start at boot, irrespective of Thorny. If Thorny is there or not, it shouldn't matter. Now what we'll do is, we will now try to save this program as, again on Raspberry Pi Pico, but this time I will give it a name as main.py. Okay. The program is now saved. Now I'll just use the open window and I will delete the main23.py, which is unnecessary at this moment. Now simply stop and run the script. You will see the LED is blinking. But it's going to get more interesting over here. How? Because when we stop the code, now I have stopped the code. Now what I'm going to do is I'm going to remove the cable. The cable is removed. Now I'm reconnecting the cable. If you see, as soon as the cable is reconnected, the LED started working. It started blinking at boot. That's the normal behavior that we expect from a microcontroller board. Coming at code, although we'll try to explain it in detail later on, but again it's very straightforward. This is a library to use the Raspberry Pi PICO's GPIO pins. This is a declaration of a particular pin. Where you want to use that pin, here should come your pin number. As said, this is not connected to any GPIO, so you don't get a pin number here. Instead, you simply get LED. You write LED here. And then you write pin.out or pin.in, depending upon you want to use it as output or input. Here we are using it as an output pin. While true gives your Python program a way to run something in an infinite loop. LED.on simply is turning on the LED. Time.sleep is giving you a delay of 1 second. You can try it. If you want lesser delay, just make it 0.5 or anything of that sort. LED.off is basically turning the LED off. Now the delays have been changed. Look at it. So this is how you write your first LED blink program, and this is how you run your program through boot mode. I'm going to turn off the Thonny now and stopping the code from here. The Thonny is completely closed, and I'm again going to remove the cable and reinsert it. And you will see the program will start working as soon as it's powered on. That's about it for this video. In next video, we'll try to understand what are the different GPIOs of Raspberry Pi PICO board, how they are used, what are the different functions of each pin, and all the details of MicroPython library as well. Thank you for watching this video. Overview of Python programming language. I know this is a specific to Raspberry Pi PICO course, and we are going to use MicroPython throughout the course, and therefore it's important for you to understand the fundamentals of Python. I will repeat it here, and please keep in mind that in order to learn Raspberry Pi PICO and in order to use MicroPython, it is not at all important that you should be an expert in Python. However, having the basic understanding of the programming language will help you definitely to learn faster and gain your Python expertise in a lesser time. So the purpose of this video is to give you the most commonly used Python lines, commands, functions, words that we will be using throughout the course, and it will also give you a kickstart to Python learning. Please keep this in mind that this is not an extensive Python tutorial, or this is not even a Python class. I do have a complete separate and detailed Python training course as well, which you can go through if needed. However, it's not a requirement, it's not a necessity to complete this course. So let's get started and learn a little bit of Python. Now to give you an overview about the Python, Python is basically a scripting language. I will not go into the history, who invented Python, because you can learn all of those things on internet. What I'm more interested in is to directly jump and start using Python, start typing code onto it. So I'll just show you what are the ways to install Python. Either you can go to python.org and directly download the official version of Python, which will come with an IDE called IDLE, I-D-L-E. Or you can use Thonny, which comes with a built-in Python interpreter. And this is also a natural choice for us because we are going to do all our experiments with respect to Raspberry Pi PICO on Thonny. So when you use Thonny with Raspberry Pi PICO, it will use the MicroPython interpreter, But if you don't have PICO connected to your computer, it will use the Python installed on your machine, which we are going to use or do now. Additionally, if you are more interested into exploring machine learning algorithms and lot many different libraries, then you can also use Google Colab, which is an online workbook based Python interpreter, and it's really impressive for what it does. It will run all your Python programs on cloud and through browser. No installation needed. All you need is a Google account and you can use Google Colab for free. So enough of the introduction, and I will jump directly onto Python. Now in order to do so, I'll just show you the python.org and then the Thorny website or Thorny's homepage. You will be using one of these two, and I suggest using Thorny because it's simpler, nothing else. And then you can experiment with officially downloading the Python installation from here. If you download an official Python version from here, what happens is your computer will get an IDE like this. I'm opening. This is called as idle. It looks very old stylish because it is. It's just pure plain interpreter with a text editor. And if you use Thorny or if you install Thorny, then you will open something like this, which is also simple but bit more familiar, bit more easier to use. Okay, so I'll just use Thorny. I'll change the interpreter from here to local Python 3 and let's get started. So what do we mean when we say it's an interpreted language? It means every line is executed one by one, and because of that it gives immense advantages over conventional programming language like C. I'll give you an example. So this is the Python shell. I can directly write a code here, print hello, and I'll just hit enter. And you see my command has been executed. Hello has been printed. If you notice, there is no semicolon over here. I'll also do something more. I want to have a variable a equal to 30 and print a. As simple as that. Now, if you notice, we have not declared a like int, char or anything. We have not given a semicolon. We are not doing any formatting when we are printing a. So this is the beauty of Python. You can directly initialize a variable and use it throughout your code. You don't even have to specify if it is int or if it is a char. You can just go on and use a variable. So I'll just have a variable now called b, and I'm going to make it a char variable or a string variable like that. And what I'll do is I'll simply do print b. Now you can see b is printed as well. So this is the shell. You type something and it will immediately be executed. Alternatively, you can go conventional way and write a code and then execute it at once. But even at that stage, the code is being executed line by line. So let's get started. I'll just write down print hello world. I'll give a new line here, although it automatically comes. Then I'll just have a variable a is equal to 30, b is equal to something, c is equal to a plus b. And then what I'll do is I'll print it. As simple as that. A very simple and the basic Python program. I will save this, let's say in desktop. My testing is the name I gave it. And now I'll simply clear this area first and then click on run. And your Python program works. So hello world and 47 both are printed on your terminal. Remember, this terminal is available here because the Python is working on computer. When you use it in microcontroller like ESP32 or Raspberry Pi PICO, terminal is still available only as long as the board is connected to your computer. If your board is removed from computer, you lose all this printing facility available through the print function on MicroPython. Talking about Python, they're all good. You can use this line as much as you want. There is another way to print this data as well if you want to combine text and if you want to combine the variables. Let's look at that. So print or addition is, and I'll simply give a comma, C. That's it. Let's run it using this run script button. Addition is 47. So you can combine text and variable as easily like this while printing. And you can also do something like this. Print. I will give a curly bracket. So addition of 0 plus 1 equal to 2. Now here I am specifying into curly brackets variable number 0, 1 and 2. After my double quote is finished, I'll just write dot format a comma b comma c. So what I'm doing is I'm simply passing a, b and c as 3 different index over here in this print function, and my code will work like that. You may also want to comment a particular line. If you want to do that, simply go and give a hash symbol, and that line is commented. That line will not be executed. Now this is the bare minimum that you can do with Python and print function. But when you are on MicroPython, you will not be doing much activities with print function, but you will be doing more activities with the if condition, the for condition, or the while condition, and likes of that. So let's try to see how we can have a comparison. Now in order to have the comparison, what I want to do is I want to have numbers input from the users and then probably try to use if condition onto it. So let me have first number in A. Now while accepting the inputs, you will have to mention that you are using int as your input, or you want int from the computer. So int input, enter first number, and I'll simply repeat this line 2-3 times. Let me call it B, C, third, second. Now, if I have to just have two numbers and print the largest one, let's see how to do that. So, if A greater than B, colon, enter, print A is largest. Have you noticed that the indent comes 1 point ahead as compared to the line number 5? So on line number 6, you will see the indent is ahead by just 1 tab. This 1 tab ahead indent means whatever you are writing over here now will be executed as a part of that if condition. So you can have as many lines here as you want, but the thing is, it will all be part of that if condition only. Now, if you want to go back to the main program indent, all you need to do is simply hit a backspace and the program will go to the main indent. This means now you're executing the main program. Now here I'll write if B is greater than A, colon, and then I'll type print B is largest. Again, I'm going to give you a heads up here. Please keep in mind that this input function will work on the PC based interpreter. On Raspberry Pi PICO or ESP32, if you are using MicroPython, then these input functions will not work if the keyboard is removed. Now let's try to execute and see what happens. So I gave first number as 85, second number as 99. So what is happening is I am casting these numbers. When you type something here, it's always taken as a text, but I'm casting them to int, and they are treated as int when they are stored. Ultimately, out of these two, B is largest, and we show it over here. Now, let's add the third variable into the picture. Now, there are two ways to make the comparison between three numbers. I'll show you the first one. So, what we'll do is, here, you can add another layer of if. So, if A is greater than C as well, then you print A is largest. It means you check if A is greater than B, and if it is greater than B, you also check that if A is greater than C, and if it is greater than C as well, then you print A is largest. Let's do the same thing here. If B is greater than A and if B is greater than C, then you print B is largest. Make sure to look at the indentation and the formats associated with it. Now, because of this indentation, the code executes this way only. Now, the third case is like this. If A is greater than, for C is greater than A and C is greater than B, then you print C is largest. Let's run this code. Let's enter 35, 95 and 101. And now you can see C is largest is printed. So this is how you will combine the if conditions together. Now this is how you can use if statement. You can use if statement by nesting them 1 times, 2 times or as many times as you want, or you can use if statement by combining using this statement and yes, there is one more, it's called OR. Now these are some of the conditional operators that are used in Python. Apart from that, all the mathematical operators remain the same, and when doing the programming for microcontrollers or embedded systems, we don't use that many complex mathematical operators. I'll just give one more example where you can use OR. So let's have just 2 numbers and okay, let me have 3 numbers. So if C is greater than A or C is greater than B, what it means is C is larger than one of A and B. Because if C is greater than A or C is greater than B, then one thing is sure that C is larger than one of A and B. Let's see how do we tackle this. Now I'll run this code. What I'm going to do is I'm going to give A as 10, B as 50, but C as a middle value. So C is greater than A or C is greater than B, means it will be less than B but greater than A. 25. Now what is going to happen? B is largest will be printed and this will also be printed because C is larger than one of A and B. This is how you can use OR statement. Again, not to mention, you can definitely always have more than 2 conditions checked in a particular loop. So if I have D over here, then my code will change like this. If C is greater than A and C is greater than B and C is greater than D, this way. So try to create your 4 number largest number finding program in this way and see and tell me if your output works well or not. Now I'm not going to save these codes because these are very elementary. I'll give a list of codes directly so that you can experiment with them. Now this is if, and the second most widely used thing that I'm going to show you now is for. Now for if is a conditional execution and for is just a looping structure. Then in if what you do is you simply check for a condition and if you execute something if it is true or not. But in for you simply repeat something as many times as you want. Just like if, there is one more construct called while, but in the programs that we are going to do, we will not be using it that often. But I'll show you how you can achieve looping using while also. So let me have 65 and let me have it, let's say 100. Okay. So what we are trying to do is we are trying to achieve looping. But first I'll try to do it with while. So while A is less than B, okay, I'll also import a library called time so that I can add delays into my program. Now while A is less than B, what I'm going to do is print something. Assume this as your piece of execution. And then what I will do is A is equal to a plus 1. Before that, let's also print value of a is a, or I'll just keep that as my line because I don't have any other execution. I'm just showing the demonstration of looping. And then what we'll do is we'll have a delay of 100 milliseconds. Time dot slip 0.1. So time dot slip will give you the number of seconds of delay, whatever you mention here in these brackets. Now let's see. B A is 65, B is 100. This program it's supposed to execute as long as A is less than B. So A is 65, which is less than B 100. So it will keep executing unless you add A to some value so that there is a chance of reaching to 100. If you don't add A so that it never reaches 100, then also we'll see what happens. Let me just run this code. 65, 89, 90, 99, and the program stopped. So what we did here is we simply looped our code. You can very well just have A is 0, B adds 10 and execute the same thing. It just doesn't matter. It will execute from 0 to 9. As soon as it becomes 10, it is not less than B and your execution stopped. If you don't have this line written, then A will be forever less than B and your while loop will simply keep executing on and on and on and on and on. This is called as infinite loop. This is where most of our embedded programs will be residing in, most of our embedded programs will be staying in. And whenever needed, if you want to run an infinite loop program, you don't even have to write down all these things. You simply write down while true and the program will go into infinite loop. But that's later. For now, let's try to understand this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I can have the same effect achieved using a for loop. Look at it. So for I, so you'll write it like this. For I in range 10. Okay, that's it. For I in range 10, print value of I is equal to I. Just to make it easier, I will execute the first one only 5 times and then I will print a line of stars as a separator between the two. So for I in range 10, value of I equal to I. Let's see what it does. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have time dot sleep here. That's why you are not experiencing the delay. Have you noticed? We have not mentioned that we want to start I with 0. We have not mentioned that we want to increment I by 1. We have not mentioned these two things. We have just mentioned I in range 10. When you write a statement like this, Python will automatically interpret that you want to start I from 0. You want to reach it up to 10 and you want to increment by 1 in each iteration. This is one way to look at it. Second way to look at it is this, 2, 10. Now what happens is, you are giving the initialization value. So you don't start from 0, you start from 2 or 3 or for that matter anything that you want. And then you will end before 10, that is at 9. You still haven't specified an increment or decrement value. Now what I'll do is, I'll make it 100. 2, 100 and then I'll give an increment value here 5. This is the third way of using for loop. So for I in range just 10, for I in range 2, 10 and now for I in range 2, 100, 5. This time you are mentioning with what value you want to increment I. So let's see, it will be 2, then 7, 12, 17, 22, 27 and all those things. It stopped at 97 because now the value of I started from 2, it got incremented by 5 and then it ended at 97. Again,
It is not even the fact that you cannot start it with 0. You can very well start from 0 as you want. Execute it. 0, 5, 10, 15, 20, blah, 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 up to 95. This can give you a very simple task of writing table of a number or multiplication table of a number by accepting it from users. So there will be lot many iterations of if, for and while that we will be using throughout this program, throughout this Raspberry Pi Pico based MicroPython learning, and there will be lot many Python tricks that we will be studying along as well. It's not important for you to understand the Python fully before learning Raspberry Pi Pico. As I told you in the starting of this video as well, it is not at all even mandatory to learn Python completely before you learn Raspberry Pi Pico. I know this video has been long, probably the longest, but I wanted to give you this overview of Python. So when we do start experimenting with Raspberry Pi Pico, you shouldn't feel alien. You shouldn't feel that, oh, you're not understanding anything. That's the reason I made this video a bit longer. I hope you will understand some fragments of Python with this, and going forward, whenever there is a new concept introduced throughout our programming with Pico, I'll explain that as well. Thank you for watching this video. In this video, we'll try to understand how we can use Raspberry Pi Pico and Pico W for embedded systems applications. Now, if you are aware of embedded system applications, or if you know about how embedded systems works, then you can skip this session. But I would still say, please continue, go on, and keep listening. Try to understand every detail as much as possible. Now, what exactly is an embedded system, and what are the IoT systems? How exactly do we build them, and how Raspberry Pi Pico can help? We are trying to find all those answers into this video. I'll try to make it as short as possible, yet I will try to not remove or not include any technical details which are important. Let's start. Now, when you want to create an embedded system or an IoT system, essentially the components that we use in an embedded or IoT systems are related or completely revolving around a microcontroller. I'll give you an example now. I'll just open my notepad and we'll just try to have a blank space first. So let's start with an example. If you want, for example, to create a very simple temperature controller, okay. Now, what is the job of temperature controller? The job of temperature controller is basically to continuously display the temperature that is being coming from some sensor, and you need to display it onto some kind of LED display. Then what it has to do further is it has to turn on or off a device if the temperature falls above or below a set point. Now, how do you turn on and off a device? You basically try to make something go on or off. It can be a heater. So let's say if the temperature falls below a particular level, you may want to turn on a heater, or you may want to turn on a cooler as well if the temperature goes above a particular set point. Then what it consists of is it also will consist of some switches using which a user can enter the set point. Now, this is a very simple embedded system example that I have taken, but you can correlate this example with many other things. Now, this is an example where I'm assuming that one is not having any idea about an embedded system. Now, let's try to break down whatever is present into this system in terms of technical interfaces. Let's say there are some LEDs as well for indication. Now, if I have to technically break it down, try to understand what all it consists of. Okay. So first thing is we have a temperature sensor. It means we need some kind of
sensor interfacing. Then we have an LED display, means we need some kind of display interfacing. Then we have a turn on off a device. Turning on off a device means very simple. Basically what you need is you need to have an input output line or output line. Similarly, there are switches, means you need input line, and then there is an LED for indication. It means output line. So usually when such system has to be designed, the way it's designed is there is a microcontroller at the heart of the system. To this microcontroller, you will connect switches as input. Then you will connect sensor as input. These two will become the inputs for your system. Then using some IO lines, you will connect an LED for indication, that becomes your output. Again, using some IO lines, what you will do is you will connect a display to display this information of temperature onto the display. And then again, by making use of some IO lines, we will turn on or turn off a particular external device. And how all of this works is essentially written inside this microcontroller in the form of a program. So your system is always reconfigurable through your program. You may want to keep that your LED should turn on or blink once when the system is powered on. You may also want to say, okay, the LED will blink 10 times when the system is powered on, just to give an indication. All of those things will be controlled here through something called as the program, which resides into the memory of microcontroller. Now this is a very simple and the most crude form of embedded system that I can tell you because of the example. Now if the example was something else, then there will be more such interfaces. Now this is the classic temperature controller example that can be used. Now how the same system converts into an IoT system, let's try to understand it. So if you have an additional network interface over here, using some means, if your microcontroller can connect to internet, then what happens is the microcontroller can send the same information onto a server, and then user can log into that server onto any mobile or computer device, open that particular URL and see the charts and trends of how your particular temperature is rising. Something like that. You can also give a feature from IoT or from this online server that you press a button over here, the server sends back a command to network, then to microcontroller, and then you turn on and off a device. Now this is in a very nutshell format, okay? It's not a final version or it's not the only thing, but this is all that is required to understand the embedded systems development and IoT as a beginner to start with. Now how PICO helps in doing all those things is PICO has IO interfaces like digital inputs and outputs. It has got a PWM signal which we'll try to explain or which we'll try to understand in coming time. It also has got communication interfaces like UART, I2C, SPI. It has got ADC as well as temperature sensors onto it. And to top it all, if you are using PICO W, then you also have a network interface circuit. So you can also connect to a wireless network like Wi-Fi and send your information over to internet. And that's where this particular pin diagram is important. You will have to study this pin diagram closely. If you see GP0, GP1, up to blah blah blah, all those pins, these are all your general purpose input output pins. You can use any pin as input or output, and each pin is also reconfigurable so that it can be used for SPI protocol, I2C protocol or UART. Don't worry, what is SPI, what is I2C, what is UART, we'll study that as we get to that stage. This particular microcontroller board is also or can also be powered directly using an external supply. So while experimenting, we are going to connect the USB cable all the time, but it's not the case. When you want to install a system based on PICO, you may want to power it on using an external power supply, where you can connect that power supply or 5-volt power supply to this board, and it will generate the required voltages for all other pins. Remember, there is one very important aspect that needs to be taken care of, that the pins of Raspberry Pi Pico are strictly 3.3 volt compliant only. What it means is, if I am taking output of a particular pin or taking out from a particular pin, then my logic 1 will always generate only 3.3 volt signal, and my logic 0 will always generate only 0 volt signal. You have to consider the same when you are giving input to a particular pin. Your input should not be more than 3.3 volt, and when it is 3.3 volt, it will be treated as logic 1. And when you give input as 0 volt, it will always be treated as logic 0. You also have to make sure, or you might have understood so far, that if it only generates 3.3 and 0 volt on output pin, then it cannot turn on anything else rather than a simple LED from its pin. So when you want to connect a device to be turned on and off or any such thing, then we will use appropriate switching circuits. Same goes when you are applying input. If you are giving any input voltage which is greater than 3.3 volt, like 12 volt, 24 volt, or sometimes even AC supply, then you need to step it down, you need to convert it, you need to optocouple it, do whatever you can, but make sure that the input that is going to controller is not exceeding 3.3 volt and it's not going below 0 volt. These are some considerations that you have to take when you are experimenting with Raspberry Pi Pico board. There are also external voltage pins like 3V3 out, you can see, with which you can power on any external sensor. But remember, the current capacity of this supply is less, so don't go on and connect very heavy load onto it. You can use it simply for connecting simple peripherals like sensors or I/O interfaces. So this is the fundamental of Raspberry Pi Pico's GPIOs and how it can be used for creating embedded applications. These documents will be extremely helpful. The Raspberry Pi Pico datasheet and the Raspberry Pi Pico Python SDK. We will be using both these documents throughout the course. I will be showing the notes with my presentation like this, but it doesn't mean that you should completely bypass or you should completely ignore these two docs. We are going to use these two docs extensively. I hope this gives you a very simple idea of embedded systems design using Pico. Let's start understanding all these different interfaces which are present on Raspberry Pi Pico. Let's experiment with them and start creating some systems around it. Thank you for watching this video.